And with that, I am very pleased to turn today's presentation over to Mr. Maury Haber, who is Vice President of Technology in the Office of CTO. And Maury, the show is yours.
Thank you very much, Chris. For today's session, we want to talk about the top 5 management mistakes that you really want to avoid in 2017. Now, this is based on what we've learned. Going out and speaking to clients like yourselves, what are the top problems that are causing incidents or breaches within your environments? Now, simply put, password management reality is difficult. We have a lot of problems. Everything from basic human nature to too many passwords to remember to people were using the same password on personal sites, multiple machines, infrastructure, servers, places that they shouldn't. How many times have we all done this ourselves? We create a simple password, we reuse it, and you know what? We know it's a risk, but honestly, we know better than to write it down or reuse it in multiple places. Now, people tend to not choose good passwords themselves. They'll use birth dates, children's names, common words, or even words like baseball, where they'll change the vowels to symbols. We know they're not good, but again, we're still human. It's a password management reality. We have problems remembering them, we have problems assigning them, and this is what comes out. Now, overall, sometimes we actually need to share those passwords. We might be an administrator, right? We created a password, we need to give it to somebody else, they may need to use it. But we forget our best practices that we got to change that password after we've shared it, especially if it's something you directly manage or if an employee terminates. That's pretty much the reality of passwords, right? We have a new employee, we have an old employee. It's difficult to change all the passwords on a router, switch, infrastructure, or even hard-coded. So those passwords just are known by people even if they're not employed by the company anymore. Now, once a potential breach happens, finding all those passwords in scripts, programs, servers, routers, switches, applications, social media is even harder, right? We don't necessarily know how to change them. Even if it's just an incident where nothing is lost, we should still go back and change all of them. But we don't. And often the only line of defense for sensitive data is education. We can segment, we can place them out, we can ask that only these people have access to a certain environment, but many times in reality, we fail. People having access to the physical floor could have access to that server as well, even though it's just in the rack next door or sharing the same space. Separation of duties is great electronically, but sometimes even in the physical world, we make that mistake and password problems can occur. Even for basic things like SNMP. It might be separated, but we've chosen to use the same community strings against multiple systems. Next slide, please. So when we think about this, we have the typical attack chain. We think about internal threats, we think about external threats. That's pretty standard in today's world. Malicious insiders, insiders doing bad, people that potentially click on a phishing link or some type of insider activity. But we also still worry about the external threats, whether it's web applications or an outside actor physically hacking into our environment. But unless you grossly misconfigure the environment, you need privileges. Those are typically passwords. They may be associated with two-factor authentication or some other mechanism, but you need privileges. Like I said, unless they're grossly misconfigured because you left the default password, you left the password blank, like we saw a couple of weeks ago on MongoDBs, you need privileges. You need an escalation path to have lateral movement, to navigate throughout the environment, potentially steal data, or have some other type of beachhead. That's the typical attack chain when it comes to privileges and passwords. Next slide, please. So what we have to think about is, with that in mind, wrap your head around what are the top 5 mistakes we all make. We all make, and we do every day with those problems and the reality. Next slide. The first, very basically, is employees and others have unnecessary access. This is simple. When you bring on an employee or even ourselves, how much privileges do they need to do their job? Have I assigned too much? And the answer is absolutely yes. According to the Verizon data breach report for 2016, 66% of insider incidents was around privileged abuse. This is a person necessarily and not necessarily doing the wrong things, but abuse of the privileges they already have. A share that they shouldn't necessarily have access to, that may have financial information, or to a database, or something along those lines. It's a really high percentage because we don't have the granularity to break out people having too much privileges or not. You have a contractor come in and they need DB admin. They need domain rights. You hire professional services. They need the rights to install the software. Is that too much? Absolutely. Was it revoked when they're done? Maybe. Was the account just disabled? Was the password changed? Well, those contractors are insiders. They have too much rights. You need them to do their job, not have the privileges left over when they're done, and make sure that people have enough privileges and no more to do their basic work. And if you're not monitoring any of that activity, even worse. It should all be logged, session recorded, keystroke logged, and everything else. So when privileges are given out, you have that document trail of exactly what they do. Now, this one flaw sounds monumental for most people to tackle. It's really not that bad, especially when you start with the concept of least privilege. Give them the bare minimum and expand it out versus giving them admin and pulling it in. Next slide, please. The second worst offender is password reuse, and we are all guilty of it. I honestly can say no matter who I've talked to, I'm not aware of anybody that doesn't do this, including myself. It's just too hard as a human being to solve this problem. Whether it's social media accounts, email accounts, doesn't matter. We are using, in some cases, the same password in multiple places. And this also includes using the same password on similar devices. If you're in charge of your infrastructure and you have routers and switches, do you have unique passwords on every one of them? I'm willing to bet no. Password reuse is not only you as a human being reusing passwords across social media, email, bank accounts, key systems, but also using it on more than one device, especially when you shouldn't. Every router and switch should have its own password. Every social media account should have its own unique password. Why? Because if that password is compromised on one device, one social media site, one email, one bank, one leak, one insurance company breach, it can be used every place else. This is what happened to Yahoo. This is what happened to Sony. We see this type of problem all the time. Password reuse leads to another type of lateral movement because the password was the same. Next slide, please. Now, credentials are shared. We know we have to do this. Two people need access to a system. You have multiple team members working on the same project. You have to share the credentials. But you're not auditing who used it. Let's say you have admin password. Everyone's logging in with admin password, but you don't know who the original user is. It's kind of bad. You need to know who's using it, even though the credential may be shared. And again, when possible, rotate those passwords after the fact. Shared credentials are a reality, especially for things like social media, where you may have a corporate website or a corporate Twitter account, and one person's tweeting or another person may tweet. You're not having two accounts. Both of them need access, but that needs to be secured, shared access, and be accountable. Because 80% of the data breaches involve the abuse or misuse of privileged credentials. Staggering statistic from Forrester. How do we keep an eye on it? How do we share them safely, but also account for who's really using it? Next slide, please. The next problem is user-defined passwords. And this is where I came up with the statement about the word baseball. Users define passwords that they can remember. Whether it's password 1234, as the title of this webinar suggests, whether it's a common word, or whether it's some type of combination of birthday and date and exclamation mark and asterisk and bracket, it's still a user-definable pattern. This makes it much easier for hackers to figure out. For example, if you use your domain password to be date 2017 bang bang, asterisk asterisk, and you change it every 3 months to now March or July, a hacker sees it once in a targeted attack, he pretty much can guess your pattern. User-defined passwords are not a great thing, especially if you're using common words. Better passwords are fully randomized. And if you've ever taken combinatorics in college and permutations and combinations, the more potential variables for a single character, the harder it would be to crack. That's why we use upper lowercase, special characters, and numbers for each character, and then add the length. When you multiply out all the combinations for each bit, or each byte, then you get a really hard combination to potentially crack. The problem is we're human. Remembering bracket 8, asterisk 4, 3, whatever it may be, is near impossible, especially when we try to go to 12, 16 characters to protect our passwords. So there are a lot of better systems out there that can help randomize them, make them easier to retrieve, or use common phrase words, systems that randomize 2 words and then put a special character afterwards, like special, asterisk, ray, exclamation mark. The word special, the word ray are randomized words, and the characters inserted in between or after with numerics are randomized as well. That type of automated or randomized dictionary combination special character makes it human workable, but doesn't rely on the fundamentals of user-defined passwords. And this is a common problem we see today, people defining their own passwords. Next slide, please. And then finally, the worst offender of all of them, even though it's number 5, is mixing business and personal passwords. Just a bad, bad, bad idea. I can't stress this enough to everyone on the call. You should never have a password that you use at home and that you should use at business. They should be completely separate. But more to this point, you should never be using your work email address for home and vice versa. We do this too. This is another human mistake. We'll send a personal email out of our business account, or vice versa. Keep them separate. Not the same passwords at work, not the same passwords at home. And I encourage people on the personal side to have a minimum of 3 user accounts, traditionally emails. One for financial, sensitive information like banks, IRS, 401k, etc. A second for all correspondence or purchases, like one place or another, like Amazon or Target. And then a third strictly for junk, for all of your junk email that you get advertising this or advertising that. And you can consider the junk also social media. Why? Because it's very easy to help you determine which is phishing and which is not. Now, all 3 of those accounts are going to have unique passwords for the actual email, but the sites they go to should have unique passwords as well. You would not expect a XYZ fake email address coming from any of the ones that you use for banks. You shouldn't get, hey, change your Amazon password going to your bank email account. You should not expect a fake financial statement from your bank going to your junk. It's a simple, easy way to screen out what belongs to what, keeping all the passwords separate, and keeping all of your accounts separate. Next. Now, the challenges with these passwords go to the next level, especially when we talk about IoT, Internet of Things. We're all familiar with the Myria botnet. It was based on CCT cameras, older ones that did not allow their administrative passwords to be changed or were not easy to be changed, and we ended up with a botnet that caused several outages at the end of 2016. We see a ton of IoT devices out there now that don't. In fact, we've even seen a class action lawsuit against D-Link from the FTC for this main problem. They have minimal role-based access. There are no enterprise-ready management tools for these en masse. It's a reality of the Internet of Things that we can't manage them beyond our own households. So if you're taking these devices into corporate environments, be aware. They may have backdoors with default passwords. They can't be joined to the domain. They can't have AD credentials. They don't have role-based access. And the traditional management tools that we've all come to love, like CA Spectrum or SolarWinds or anything of that nature, can't manage them, let alone pass them. Honest challenge. Legacy systems, same problem. Many of them have passwords that can't be changed after they're put into play. If any of you are working into enterprise environments, you may have had systems where you set the password once and you can never change it again, and that password is set at time of installation. You know what those applications are. There's nothing you can do for it. And when someone uses that password, there's no auditing capabilities. They're legacy systems. Now, modern systems also have a challenge. The password complexity and history is basically complex. I can tell you from my own company, my own MDM solutions, I can't use the same password within a year, and it cannot have overlapping characters. So that patterned approach of date, time, etc., it don't work. That means that I have to come up with unique passwords every single time, which is every 3 months, just even for my phone. That makes it really hard, and most people still have to write it down, which is, again, not where we want to be. Also a challenge is two-factor everywhere. Everybody's moving to it. Whether it's an SMS, which is not a great recommendation, but better than nothing, to having a key fob, a USB key, or a YubiKey or something else, it's going everywhere. It adds time and complexity. It's needed, but it's still a challenge with our passwords today. Next slide, please. So what do we end up doing? They're straight up recommendations, and I covered a lot of these in the slides that we've already worked through. Never reuse the same password. I've already stated this in the previous top 5 mistakes. They say that if you repeat something 3 times, it generally sticks in someone's mind. Never reuse the same password. That's the 3rd time. Don't use it between home and work. Never use it between financial institutions and social media or even email. And for an administrator account, get rid of it. Don't use admin accounts. Use a standard login account. Desktops, servers, workstations. You should never log in as an admin to do your daily work. That's how malware and other things get into systems, especially with techniques like pass the hash. You should never tell anyone your password. Never. If you do need to, change it. Sounds crazy, home or business. If you're going to share your password, you're putting it out there. Now, I understand home, children, things like that, but if you ever have to share it, don't. Okay? Not a good idea. Change them all frequently. You change your smoke detector every 6 months. For home, change them every 6 months. For business, it's by policy. Typically every 3 months, more aggressively every month. Even more aggressively using solutions every time it's used. I.e., every time you use the password, change it. And there's plenty of great technology out there, like from BeyondTrust, to actually accomplish that goal. For individuals, password managers, tons of them out there. One's built directly into the operating system, like Apple iCloud Keychain. It'll automatically recommend ones, randomize them, and fill them in. Nice and simple, nice and clean. And it'll have that complexity we've been talking about. It's not even really human readable. And for organizations that use enterprise password management, use them to the extent capability. That will track the passwords, know who's using them, release them, randomize them, etc. If your application can support 64 characters for a password, use all 64 characters. It just makes it that much harder to randomize them, for them to be leaked, written down, and that the randomization keeps them moving on a rotating basis. So even if someone stole them once, it's not going to be valid for very long. Next slide, please. Now, with all these recommendations in mind, I just want to present to you what BeyondTrust offers real quick before turning it back to my colleagues at cStor. We have the BeyondTrust Privileged Access Management platform called Beyond Insight. We provide an enterprise password solution that scales from the small to medium-sized business all the way up to the enterprise. It's best-of-breed technology for automatically talking to all your applications, servers, workstations, infrastructure, routers, etc. Randomizing those passwords, storing them encrypted, allowing you to check them in, check them out, and even provide full session recording capabilities so that you could search through a session, find keywords, find what users have typed, and even find what applications have been run. All in a single appliance, software, virtual machine, or available as an AMI in Amazon. Now, for the privilege side of the house, we offer least privilege on Windows, Unix, Linux, and Mac, and that allows you to have everyone log in as a standard user, and only the application itself runs as an admin. No one ever types in their ex-admin password or a username or root to run an application. BeyondTrust tackles these top 5 management problems with this platform and helps you get the privilege escalation portion out of the attack chain. Next slide, please. And viewing it in this context, we see the visibility and control directly in the middle. If you can remove that portion of the attack chain where privileges are no longer static, they're rotating and being managed, you're better to secure your environment and prevent that lateral movement. Next slide, please. With that, I'll turn it back to my colleagues over at cStor, specifically Mike Odell, for a little bit of a case study on Applied Research Associates. Matt?
Hey guys, thank you. So Applied Research Associates is a defense contractor headquartered out of Albuquerque here, and they recently, as doing a lot of work with federal data, must comply with the NIST 853, which covers security practice and privacy controls. They're sort of a mid-sized corporation. There are about 14 divisions around the country. They have a large number of network devices, and all these multiple sites are managed by different employees. They have a large number of internal software development. It's a big piece of what they do as a company. And as part of that, the software developers require elevated privileges and permissions for their development. So they have a number of local sysadministrators, and those guys are often bamboozled into giving local admin accounts to a lot of their developers to enable this code development. Okay, the next slide. Hello?
Sorry, it's up. Do you see it there, Matt?
Yeah, okay, there we go. So they have a couple of, I spoke with their sysadmins or their operations manager, and they said, if the users have local admin, we will never become NIST compliant. And the reason for that is they need an auditing platform. And then they also said the number one thing we can do for security is to remove the admin privileges. And everything, as we talked about earlier, once that privilege is elevated, that really is the biggest thing in the attack chain. And so when we worked with them as part of a broader solution, we realized we can address 23 of the NIST security requirements with dealing with these local admin privileges. And the password safe portion of this that they're implementing will actually allow them to manage these admin accounts on their network devices and on their servers, and also allow for auditing capacity. That is one of the biggest requirements. Can they actually see who did what and how they did it? And then the other piece of the privilege escalation will allow them to actually, their developers, to actually look at their processes they're running and elevate the pieces that they need without having to give them the process that they need, or the elevated privileges. And they're going to, in the future, use a lot of these password management and the elevated privileges to manage their network devices and not have to give out the privileges to everyone around the company. So they're very pleased so far. They've spoke with a lot of the clients, and everyone seems pretty happy that they have a solution to a lot of these problems. Thank you.
Excellent. Thank you so much, Matt, and thank you to Maury. Great information and obviously very timely, great reminders, but good detail as well. At this time, we will open it up for questions. As a reminder, if you have any questions about today's session, please post them to the questions pane in the GoToWebinar control panel. And it looks like we do have a few coming in, likely for Maury, but I'll just ask Matt to stay on the line as well. First question, what do I do if I have an application or system that cannot have its password changed? Great question, probably for Maury.
Certainly. So what you can do is actually in a threefold answer. Certain applications, when you actually set them up, require a password that can't be changed. And they're more legacy applications like PeopleSoft or SAP. The first thing to do is make sure that anybody that potentially knows that password is isolated. I know that sounds nutty, but what it means is that anytime that password is used, it goes through a proxy via segmentation, and the entire session is recorded and documented. So that even if that password was leaked, your access to that interface, that SSH command line or something else, is controlled. And then anything that's done with it is, hunkered down. The other two portions of that means that it could be in a program, compiled, or in a script. From BeyondTrust, we offer a public API, whether it's Python, C, .NET, Java, etc., where those passwords can be called using a certificate and then injected into the code or the script. So as the password changes, it's no longer hard-coded in clear text or compiled in the application. The current password is retrieved and then inserted appropriately. So we can handle it for all three use cases.
Excellent, thank you. Next question, how would you handle passwords in scripts or hard-coded in applications?
Actually, thank you. That's actually just what I was referring to. It is the public API. It's available from Beyond Trust for free. cStor is familiar with how to actually implement that. It's also available on GitHub, something that can be used so that you don't have any violations of clear text or compiled passwords.
Thank you, Maury. We do have a few more, and we've got a little bit of time. We'll squeeze them in. How do you manage applications that need passwords, but I do not want to share them with the end users?
Excellent. So one of the capabilities of our enterprise, our PowerBroker password safe technology, is the ability to run applications using Remote App. So essentially you use Microsoft Terminal Services and Remote App to register the program, and whether it's an FTP program or a mainframe terminal server, it really doesn't matter what. The end user then would request access. The remote session opens up like RDP. The application runs maximized. There's no desktop or icons. And the using AutoIt scripts fills in the passwords for that session into the appropriate fields. The user is documented as requesting the app. The session can be recorded, but the passwords are filled in, fully encrypted directly into the app so that the end user never even sees them. This allows you to do everything from web applications to social media, like I talked about, for Twitter, Facebook, or even Office 365 or Google, to local apps. You then control who has access to it and the credentials being deployed.
Great, thank you. Another question, do you consider SMS a safe method for two-factor authentication? I know you mentioned that briefly earlier, Maury, but can you speak to that a bit more?
Sure. Actually, I do not, and there was actually a government recommendation to stop using it. It's better than nothing because it does add a layer. However, it's a high-risk method for two-factor authentication, even though many services still use it, because it's quite easy actually to spoof or become the man in the middle for an SMS attack lately. Again, it's not the best practice, but it's better than nothing. So I would recommend other forms of messaging beyond just straight SMS for two-factor.
Great, thank you. Last question, we'll get one more in. How do you feel about biometrics as a password replacement solution?
This is a personal opinion on this one. I do not. I believe it's a good two-factor approach, but I would not rely on it solely. Biometrics is a database like any other type of database. Yes, it can be encrypted, it can be parsed, broken into pieces, but if you look at it in its raw fashion, it does contain traits, fingerprints, eyes, anything like that, that cannot be changed. Your identity based on biometrics can never be changed. If that database is compromised, like lifting your fingerprint, it's game over. It can be used in any other technology that uses that similar type of authentication method. So I am not a fan of biometrics personally. I think it's fair to use it as a two-factor, but not as a replacement mechanism.
Excellent, great information. Thank you so much, Maury, and again to Matt. That actually concludes our questions for today. Thank you, everyone, for your time and attention. Before we close today's event,